Okay, hello guys and welcome to another one. So on this video we'll be looking at motion in one dimension, and this is the question we have. It reads as follows. It says the truck mechanic conducts tests after the repair. A truck starts from rest at a traffic light and accelerates for 4 seconds in an easterly direction. A person on the road measures the change in position during equal time intervals. The results obtained are recorded in the table below. So this is our table, and then they say on 4.1, for this test write down the following. Firstly, the independent variable. What is our independent variable in this case, guys? Is going to be the time. So that's our answer for this question. The independent variable is the time, which is measured in seconds. Okay, the independent variable is always found on the x-axis in this case. Okay, and we now move on to the dependent variable. The dependent variable in this case is going to be the position. Okay, and our position is measured in meters. That's how we'll answer this question. Then they say use the information in the table above and draw an accurate position time graph on the graph paper on the attached answer sheet. I do not have a graph paper, guys, so I'm just gonna draw this ruler using my ruler here, but I need to figure out how to use this ruler first. Okay guys, I'm failing to use my ruler, so I'm just gonna draw this freehand just to show you the picture of how the graph should look like. So this is what I'm going to have. Firstly, I have to label my axis, and on the x-axis I'm going to have my time, and my time here is measured in seconds. On the y-axis I'm gonna have my position. Can write delta x or x in meters, but you should write this in words actually. Let's do that. So we'll have time on the x-axis, then this side will have position. I just can't write properly, but yeah, this is what you'll have. Okay, I hope you can see how this is supposed to be done. Need to remove this. Okay, I'm moving this because I have to write my values there, guys. So let's look at our scale. Now we can see that our scale starts from 0 going up to 40. So that means on my graph here I'm gonna have 0 for the position. Remember, position is this side, position measured in meters. Okay, so my position is on the y-axis, so what I'm going to have is 0, and look at my scale, it goes up by 10. So I'm gonna have 0, 10, 20, 30, and 40, or I can have 0, 5, 10, 15, 20, whichever way you want to have your scale. Then if I look at my time, it starts from 0 and ends up at 4. So here I'm gonna have 1, 0, 1, 2, 3, 4, and maybe end up at a 5. Then I'm gonna measure my points. 0 corresponds with 0, so it should be here on the origin. And then 1 corresponds with 10, so I will have another point here. And then 2 corresponds with 20, so this point will go with 20. And then 3 corresponds with 30, So this point will be here, and then 4 corresponds with 40. So my 4 is here, and there's my 40. Then I'm gonna join these points. I'm supposed to get a straight line, and you can see my line is a bit skewed. That's because I'm not using a ruler. But if you are drawing this graph, guys, you are supposed to use a ruler. Okay, once we are done here, and remember, you'll be using your graph paper, so your graph should be neat, it should be straight, unlike this one of mine, because I'm not using a ruler. But I'm just trying to show you here how is it that you are supposed to draw your graph. So this is how your graph will look. Firstly, it will be labeled the y-axis position, the x-axis time, then we'll have your scale as well. Okay, that's how you draw the graph. And now we move on to 4.3. 4.3 says calculate the gradient of the graph. But before we calculate that gradient, guys, I want to ask you this question. What does the gradient on the position versus time graph represent? Well, if your answer is velocity, then you are very much correct. So for 4.3, if they say we have to calculate the gradient, they are essentially saying we have to find the velocity of this particular track, and the formula for velocity is v is equal to it's going to be delta x. V is equal to delta x divided by delta t, which can be expanded to final position minus initial position divided by final time minus initial time. Okay, how are we going to find those times? We can use any points on our graphs, but I'm gonna work with the first point. I'll label this point A, and the second point B. The first point, which is point A, is 0 and 0. Those are the coordinates. The last point B is 4 and 40, but you can use any points, guys. You can use this point and this point. You can use this one and this one. You'll still get the same answer. Okay, so now I'm gonna say this is my initial. Firstly, this is my initial time, and this is my initial velocity. Remember, what is y is your, not velocity, guys. Here it's supposed to be a displacement or position. Initial position, initial time, and then here I'm gonna have final time and final position. From here I'm gonna substitute. You can also use the gradient formula, because they are saying find the gradient anyway. So you can use y2 minus y1 divided by x2 minus x1. Now what is our final time based on this formula? Our final is 40 minus the initial, which is 0, divided by the final time, which is 4, minus the initial time, which is 0. When we say 40 divided by 4, what are we going to get? We are going to get 10 meters per second. That is the answer we are going to have. And we can add direction here to say that this is going to the easterly direction because it is positive. Okay, so that's how you are going to basically answer this question. This is how you draw your graph. This is how you answer the questions, and this is how you find your velocity, aka the gradient. I hope, guys, this made sense. Please rewind if you didn't understand, and likewise, guys, like and share the video, please. Don't forget to subscribe as well. See you on the next one.